chemistry department at USC Dornsife kind of covers all of the modern areas in chemistry, using the very cutting edge of all of the technology that science gives us to try and solve chemical problems. We've got great strength in a number of important areas, in hydrocarbon research, in laser science, and theoretical chemistry. We have 2 Nobel Prizes in the department.
We have quite a bit of strength in the traditional disciplines like physical, organic, inorganic, biochem, but we've also worked very hard in building those disciplines to make sure we represent some forefront areas like nanoscience and chemical biology. Energy-related research is a very big component of what goes on in our department. It's all really about building strength while maintaining our disciplines.
I think it is important for students to get them excited about chemistry very early on. And the way to attract them is just to get them involved in research in the lab, and they see how fun it is.
Honestly, I've learned a lot about organic chemistry. Even though this is a mainly inorganic lab, I learned so much about organic chemistry and how things work. We're trying to store energy. We're trying to couple it with solar collectors to essentially store energy in a feasible manner and in a way that we can use.
So nature knows how to do this extremely well. It can use sunlight to generate a variety of different difficult reactions, and we would like to take inspiration from nature and develop materials that could do similar transformations.
So the research in my lab in chemistry is related to understanding at the very smallest level, microscopically, what's going on when chemical reactions take place.
We're looking to see how a nanoparticle, when it's energized by light, can transfer its energy into a different compound. And when this transfer energy happens, we can use that energy to attack specifically a certain type of molecule. And in my case, we're looking at attacking cancer cells.
We do some work even in organic transistors, where we're developing organic materials to try to come up with the next generation of LEDs and solar cells that will have a lot of properties that you can't do with the traditional materials. Solar cells and LEDs were developed in the 1950s and 1960s. Electricity is applied to a set of materials and light comes out of the device. We really do everything under one roof, and that's really part of my philosophy of what I'm trying to give students in my lab, whether they're undergraduates or graduate students. It's really to get the full picture, to take an idea into the laboratory, to synthesize the material, to purify it, to make a device with it, to test it and see whether that original idea was a good one or not.
Sometimes the outcome of an experiment is quite unexpected, and that's the beauty of chemistry.
So one of the things that's an advantage for a Dornsife undergraduate is that when they're working in a lab, they're going to be working with a PhD student, they're going to be working with postdoctoral students who are very highly accomplished researchers, very often from all over the world. They'll be working with faculty, they'll be working with visiting scientists, and very often they'll actually go and do research in a lab overseas. That whole experience is what research brings to an additional component of undergraduate education.
The chemistry labs are actually being designed so that we can now start doing a wide range of experiments that really weren't possible in our old chemistry labs. Anything we can imagine we can do in these chem labs.
So they often say that chemistry is essential science, and it's really true in terms of careers that chemistry prepares you for. Chemists go from working in pharmaceutical companies, in biotechnology companies, in semiconductor manufacturing technology, computational design. A lot of chemists get trained as computational scientists. So we have our graduates go on to jobs in all types of sectors.
It's kind of exciting that some of the chemistry that's gone on in our laboratory is actually being applied in real life. We develop red and green emitting compounds that are going into about 10 million cell phones a month. They're going into the next generation of television screens. All of those materials developed here at USC.